Lesson 37, Using Scientific Notation. Very large or very small numbers are often written in scientific notation. So, in this table that they've given us, we have scientific notation and standard form. What you have to remember for converting scientific notation to standard form is that the exponent that they give us, which is right here, this 2, is telling us how many times we need to move our decimal and in what direction. So, what we're going to do is we're going to rewrite the coefficient part. Rewrite the coefficient part of the scientific notation number, and because that 2 is a positive 2, oh, that was a 0, not, I was thinking 2, I'm sorry. Let's okay, so since that exponent of 2 is a positive 2, that means that we're going to move our decimal 2 times in the positive direction. If you think about a number line, pretend that's a straight number line, we know that positive numbers are to the right and negative numbers are to the left. So we're going to move this decimal 2 times, which gives us 108, because the decimal is now behind the 8, just as so. Now, on the next one, it's a 3, and those are written as subscripts instead of manuscripts for whatever reason, or instead of exponents. And please ignore that. If I have 1.08, my coefficient part, and I want to change it to scientific notation, or to standard form from scientific notation, I'm going to move it, that exponent of 3, which should be written up here, not down there. I'm going to move it 3 times in the positive direction. 1, 2, and 3. Because I have this empty space, I have to fill it with a place filler, which is going to be a 0. So my number in standard form would be 1080. Okay, and I want you to go ahead and finish those last 2 on your own paper for me. On problems like this, I have 1.08, the same number we've been dealing with, but this time we're raised to a negative exponent. Whenever it's raised to a negative exponent, we have to move towards the negative direction, which means, I don't know why my pen is so bad right now, which means that I will have no go. Okay. I will have 1.08, and I have to move that decimal 1 time towards the negative direction, which is to the left. So my decimal is now here, which means that my new number in standard form is 0.108. Okay, that's an 8. Go ahead and finish the rest of the table on your own paper. So on this example, it wants us to write each number in scientific notation. Whenever we have a number that isn't obviously a whole number, okay, there's no decimal shown, we know that the decimal is understood to be at the very end of that number. And for a number to be in scientific notation, there are a few rules that you have to make sure that you remember. One of those is that for a number to be in scientific notation, there must be 1 non-zero digit in front of the decimal. You should write these rules down. 1 non-zero digit in front of the decimal. If I had a better working pen right now, then I would write them down for you, but it's no-go. Not going to happen. Actually, maybe I can just type it in. Hold on just a second. We'll do that. Okay, so the rules for scientific notation. The coefficient part must be, or must have, 1 non-zero digit in front of the decimal, and it must be being multiplied by a power of 10. So that means 10 with an exponent. Okay. So this, and let's take it back to full screen. Alright, so those are your rules. Make sure you get those in your notes. Very, very important. So we've talked about where our decimal is, and for it to only have one non-zero digit in front of the decimal, I currently have 1, 2, 3, 4, 5, 6, 7 digits in front of the decimal. I can only have one, and it must be a non-zero digit. So these are my only two non-zero digits. Non-zero meaning not zero. So it has to be behind one of these two things. Now if I move it to right here behind the 9 where my pin is currently located, then I would have how many digits in front of the decimal? I would have 2, and I can't have 2. I can only have 1, and it must be a non-zero. So I have to move it to this location right here, because that will leave me with one non-zero digit in front of the decimal, which is 1, 2, 3, 4, 5, 6 moves. So I would write this as 4.9, and I drop those zeros. As long as there's not a non-zero behind them, I can drop them, times 10, and I moved it 6 times, so it's to the 6th. To get back to the original, I would have to move to the right 6 times, which means it has to be a positive 6. On this one, same rules apply. I have one digit in front of the decimal, but it's not a non-zero. It is a 0, and I can't have that. So I want you on your own paper to work this one really quickly on your own. I hope that you thought that the 0 should go between the 9 and the 3, because that would leave us with one non-zero digit in front of that decimal, because we can drop all these other zeros, which means I have to move 1, 2, 3, 4, 5 times. So I would have 9.3 times 10, and I had to move it 5 times, which is going to be a negative 5, because to get back to the original I have to move to the left, which is negative direction. Okay, wants us to find the product. Write the answer in scientific notation. So whenever we're finding the product of two numbers that are in scientific notation, we can do something to make this much, much easier for us, and that is to regroup. I'm going to regroup coefficients with coefficients and powers of 10 with powers of 10. You can see that these two things are obviously being multiplied, but these parentheses touching, I hope that you remember, means that we are also multiplying the entire quantities there. So I'm going to rewrite these in parentheses, and I would love for my pen to just magically start working. Any chance? One. No. Okay. Alright, so I have 3.2 times, and the other coefficient is 4.3, and then I'm going to put the other set of parentheses are going to be my powers of 10. So I have 10, which is to the 7th, times 10, and this 10 is to the 2nd. Now what we can do is just do the multiplication that's indicated. So 3.2 times 4.3, punch that into my calculator, gives me 13.76. Okay. Parentheses touching, we said, means to multiply. And what I have now is I'm multiplying by the same base. Well, I hope you remember that when we multiply by the same base, I can add those exponents. So I get 10, and 7 plus 2 gives me 9. Now, the only thing currently wrong with this is that it's not in scientific notation. It looks like scientific notation, but it says specifically to write it in scientific notation. Take a second to see if you can figure out why it's not in scientific notation. So the reason that it's not in scientific notation is because there are currently 2 digits in front of that decimal, and I'm only allowed to have one non-zero digit, and there are 2. So I have to move it one time, so that there's now only one digit that's non-zero in front of the decimal. So I have 1.376 times 10, and because I moved it that one time, I have to add 1. Because to get it back to the original, I would move it towards the positive numbers. That means I'm adding 1, so I have 10 to the 10th power. Final answer. The same thing can work whenever we're dividing. In this case, we're going to regroup the exact same way. I'm going to put coefficients with coefficients and powers of 10 with powers of 10. So what this is telling me is I'm taking 6.8 divided by 2.5. So 6.8 divided by 2.5, that gives me 2.72. Remember, parentheses touching means I'm going to multiply. And whenever I am dividing by the same base, I subtract my exponent. So it's going to be 10 to the 5th minus the 8th, which is going to give me 10 to the negative 3rd power. Final answer. So I want us to compare, and I want you to practice this one on your own paper using the rule that we just talked about to figure out which one you think is less than, greater than, or equal to. So on your own paper, go ahead and solve and see what you come up with. Alright, final example here. The speed of light is 3 times 10 to the 8th meters per second. If Venus is 1.08 times 10 to the 5th meters from the Sun, how many seconds does it take the light to reach Venus from the Sun? Write your answer in scientific notation. So, first of all, we're talking about a couple of things. We're talking about speed, and we're talking about a distance, and we're talking about time. That speed can also be considered a rate. So we're actually talking about the DIRT formula. Distance equals rate times time. And there are going to be lots of times that we use this formula to help us with lots of word problems. So the distance from this example, I have 3 times 10 to the 8th meters per second. And I have 1.08 times 10 to the 5th meters. Which of those sounds like a distance to you? I hope you just said the meters, because whenever I'm dealing with meters per second, that is a rate. That is how many meters we're being able to travel per second. So my distance is going to be 1.08 times 10 to the 5th, which must be equal to, I already told you that the rate is 3 times 10 to the 8th, and that's my rate. So I plug that in for R. It's being multiplied by the time. So what I want you to do is I want you to solve for T, the time, on your own paper. And you're going to have to use something that we've learned today and what you know about keeping equations equivalent. What must I do to get T by itself? So, on your own paper, make sure you're taking good notes, and I'll see you in class tomorrow. Have a good night.